Hi, welcome to my video on find the value of theta given cos or sine in a quadrant. Now we're beginning all the previous videos. We're now going to put them together and find the value of theta. Find the value of theta. Theta is in standard position and from 0 less than or equal to theta less than 360. So the answer is going to be from 0 to 360. And let's do some examples. Sine equals 1/2. Theta is in quadrant 2. So we'll draw the circle. And theta is in quadrant 2, so that means the terminal arm is drawn out in quadrant 2. And theta is this rotation from the initial up to here. This is theta. And because it's a terminal arm, then we will drop a perpendicular to the x-axis. And you notice that we have sine is 1/2, so sine is the y value. So in this triangle, the y is 1/2. The radius of the circle is 1. The hypotenuse of the triangle is 1. This side is √3/2. So across from 1/2, we have a 30, and this is a 60. So we have a reference angle of 30 degrees. So that means that in the second quadrant, theta is 180 minus the 30, so theta is 150 degrees. Okay, that's one way. You could use the calculator and go inverse sine on the half, and you'll get a 30. But again, when you do with the calculator, it doesn't always give you the exact answer. You got to interpret. So if you did the calculator and got a 30 degree, that would be a 30 degree reference. As if in the first quadrant, you put 30 here and then work it out. Now we have a B, second quadrant. Oh, sorry, this is second quadrant. This is the third quadrant. So the third quadrant is the reference angle. The terminal arm is in the third quadrant. The rotation for theta is all the way around right to here. And so we have notice that's x, but if we could leave it like that, or we can go, the cos of the reference angle is √2/2. That means cos is still the x. So what angle is x is root, so we drop a perpendicular to the x-axis. Cos is the x. The reference angle is, we've got a positive number. If you're going to use your calculator, you need a positive number. But if we don't use the calculator, cos is the x. Notice that the x is √2/2, and it's negative in this quadrant. And notice that that's √2/2. This is √2/2, but it's in the third quadrant, so this is negative. And so 45, 45, right triangle. This angle is 45. So the reference angle, without using the calculator, is 45 degrees. And theta is 180 plus the 45. So it's 225. I just want to get back to this one up here. I put it in the second quadrant. I said sine was the y. The x was √3/2, but really, if I do it this way, this is negative because the x is negative in this quadrant. So it still makes no difference to the answer. I didn't put a negative on this triangle. So if I put that negative in here, then this is √2/2 negative also because the x and y are negative in this quadrant. And we pick up the reference angle of 45. So if you took cos of 225 and hit the in the calculator, you would get, if you did the calculator, you get a negative 0.707, which is √2/2. C, we have a fourth quadrant angle. So we draw the terminal arm out in the fourth quadrant. And we have sine is the y. So we drop a perpendicular to the x-axis. So y is a negative √2/2. Sorry, negative √3/2, negative √3/2. So that's hypotenuse of 1. So this side here is 1/2. So if that's a half, 30 is opposite of half. Opposite root 3 over 2 is 60. Again, the x is positive in this quadrant, the y is negative, so the reference angle is 60 degrees. And that means that in the fourth quadrant, theta is 360 minus 60, minus the reference. So theta is this rotation all the way around right to here. That's theta. Up in the second quadrant, theta is this rotation all the way around till you get to here. And theta is 300, and 360 minus 60 is 300. Again, if you took your calculator and did the sine of 300, you would get a negative 0.866. Root 3 over 2 is 0.866. If you did an inverse on this, if you're going to use the calculator to work it out, remember the cos of the reference angle is root 3 over 2. If you're going to use your calculator, then sine to the negative 1 on root 3 over 2 will give you a reference angle of 60. Remember, sine to the negative 1, root 3 over 2 is 0.866 as a decimal. So it'll give you 60. So be careful plugging in root 3, typing in root 3 over 2 in a calculator because of the division of the fraction. D, notice we don't have a half, we don't have root 3 over 2, we don't have root 2 over 2, so we have to use our calculator. So we're in 100, or sorry, draw the circle first. 90 is right here, 180 is right here, so theta is between 90 and 180. That means we have a second quadrant angle. So theta is this rotation to get between 90 and 180. So the reference angle is in here. So if I want the reference angle, the cos of the reference angle is positive 1 over 3. So now I'm going to use my calculator and turn on my calculator. I got a cos, so inverse cos of 1 division 3, and that gives me, did I do inverse cos? Yep, okay. Just to make sure again, inverse cos of 1 division 3, and I get 70.5, so that gives me 71. So that means the reference angle is 71 to the nearest degree. So the reference angle is 71. So that means that theta is 180 minus the reference of 101, so it's 109 degrees to the nearest degree. Again, notice I had to use the calculator because I have a 1/3, and it's only if I have a half, root 2 over 2, or root 3 over 2, that I know what my special triangles are. Just be careful. And let's do some for practice. Find the value of theta. Cos theta is root 3 over 2. Theta lies in the fourth quadrant. So let's draw the diagram. Theta lies in the fourth quadrant, so the terminal arm going out. Right triangle always goes to the x-axis. The cos is related to the x. So in this triangle, this is the x. So cos is the x. So root 3 over 2 is the x. So the y is a half because the radius of the circle and the hypotenuse is 1. Opposite of half is 30. Opposite root 3 over 2 is 60. So that means the reference angle is 30 degrees. And because it's a fourth quadrant, theta is 360 minus the 30. So that's 330 degrees. So if we rotate all the way around like this and come to here, that's theta. That's 330 degrees. And remember, root 3 over 2 is 0.866. .866. So how do I check it? Okay, let's take the calculator. Here comes the calculator. I'm going to clear it. So the cos of 330, the cos of 330 should give me 0.866, because root 3 over 2 is 0.866. Perfect. So I know I'm right, because cos is positive. Cos is the x, and cos is positive in the quadrant 1 and 4. So this value is positive. Cos in the fourth, everything lines up. Okay, let's do another one. Again, pause the video. Now this time it says it's between 180. So this is a 90. This is 180. This is 270. This is 0, or it could be 360 if you want, all the way around. So between 180 and 270, so the terminal arm is right there. Right triangle goes to the x-axis. Notice the right triangle never goes to the y, always to the x. So theta is this rotation all the way around here, right to here. So that's theta. And sine is related to the y, and the hypotenuse, or the radius of the circle, is 1. And so we have a negative, so the y is a negative root 2 over 2. That makes sense because it's going down. So because that's a root 2 over 2, then this side is going to be root 2 over 2. And on this side, x is negative. And so root 2 over 2, root 2 over 1, this is a 45-degree angle. This angle is also 45, so the reference angle is 45 degrees. Because the reference angle is between the terminal arm and the x-axis. So I can extend that over there, but don't make any difference. And so this is a third quadrant, so third quadrant is 180 plus the reference. So I get a 225 degrees. And if you check your calculator, the sine of 225, remember, root 2 over 2 is 0.707. But if you use your calculator, you're not going to get root 2 over 2. You're going to get 0.707. So let's check the calculator. I'm going to clear it. We're going to do the sine of 225. And we get negative 707. Negative decimal 707. Perfect. Root 2 over 2 is decimal 707. Root 3 over 2 is 0.866. Just check with your calculator. And the last question to do is, we have a theta is in quadrant 2. So that means the terminal arm is in quadrant 2. So theta is this rotation right here. And we have perpendicular goes to the x-axis. Sine is related to the y. And in this case, we can't put it in. We got to use our triangle. We got to use the, should I say, got to use triangle. We got to use our calculator. So we put our calculator down, and we want to get, we go inverse sine on 0.6154. Close it off, and that gives us 37.9 degrees. So that's 38 degrees. So we got to use our calculator on this one. So sine to the negative 1 on 0.6154 equals, and that gives us 38 degrees. Notice it's positive, so the reference angle is 38 degrees. I could put this one in if I want, and that one would be 52 to make up the 90, but I don't need it. So if the reference angle is 38 degrees, then theta is 180 minus the 38 degrees. So theta is 142. 142. Perfect. That's the value of theta. So that brings us to the end of finding the theta in different quadrants. Notice I do these special right triangles, but if you don't have a 1/2, root 2 over 2, root 3 over 2, you have to use your calculator and you have to go inverse. But just to show you, if you have the sine of theta is a negative 0.1124, this is an extra one, you have to go the sine of the reference angle is 0.1124. If you use your calculator, it's best to make the decimal positive, and then you can pick up your reference angle by going sine -1, 0.1124 to get, because if you plug this in your calculator as with the negative, the answer you get, you have to interpret, and there's more math to be done to explain why. So just to finish that one off that I started, just to show you, because it's negative, and I'm going to use my calculator, inverse sine of negative, or sorry, not to put the negative in, 1124, my reference angle comes out to be 6 degrees. So that then you, whatever quadrant you have it in, and you can go 180 minus that, 180 plus that, or 360 minus 6, or it was in the first quadrant, just a 6. So just to mention that, if you're going to use your calculator, make sure you keep the number positive to get the reference angle, and then put it in the correct quadrant, just to make sure. If you use a negative, you could get a different answer. If you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.